Okay, we are going to make a little Fibonacci spiral here. So Fibonacci theorem is just a mathematical theorem, and we're going to use the Pythagorean theorem to prove it. So what we're going to do is we're going to make a little right triangle. Each of these squares is ½ an inch across. So when you use a ruler, you can see that ½ an inch right there versus ½ an inch right there. Okay, so the idea is we're going to make a right triangle. Just like kind of start over here. Like as we kind of look at it, right, I'm going to put it probably in the lower, because it's going to like spiral out like that. So I'm going to put it kind of in the lower corner here. Let's just do right there. So I'm going to go 1 by 1, so 1 box by 1 box. Even though it's ½ an inch, we're just going to kind of focus on that size as we do this. And then I'm going to draw the hypotenuse of it right here. Now, I know that these lengths are 1 and 1, right? And so when I show like the work for this, right, it's going to be 1 squared plus 1 squared equals c squared, right? So 1 times 1 is 1 plus 1 is c squared. So that's 2 equals c squared, which I have an eraser here. We're going to square root here and square root here, and we're just going to leave it as the square root of 2. Rather than putting it as a decimal, we're just going to leave it as the square root of 2. I'm just going to do real teeny tiny hypotenuse label right there, okay? Now, my next square, the short leg is still going to have that length of 1 or ½ an inch. 1 box is ½ an inch. So what I'm going to do is I'm just going to use my ruler here to make a right angle, right? So it's a 90-degree angle right there. And I'm going to put it so that is ½ an inch. So right about there, okay? So just like that, okay? So this is going to be kind of, it should be as precise as you can make it, right? But as we do it, right, we can see that as I draw my hypotenuse, that hypotenuse is going to be longer because the B side is root 2 instead of 1, and root 2 is bigger than 1. It's like 1.4, right? So if we actually figure that out, let's see here. Give me a blue calculator real quick. All right, I take the blue calculator, I throw a 2 in there, and I just do that. So it's 1.4. So this length is technically, is technically 1.4, and so this longer side becomes that 1.4. Okay, but we're just going to leave it as root 2. Now what happens is we have this 1 and we have root 2 here, and we do the math for that. We get 1 squared plus root 2 squared equals c squared. It's a test question very similar to this, right? So we get 1 plus these cancel out, 2 equals c squared, so we end up with 3 equals c squared. We square root and we get root 3. And so we can see that the hypotenuse of the next triangle becomes root 3. Now, you can probably see the pattern here that this is going to make as we start increasing the size of our triangles, right? Again, I want to make another right triangle with our A side as ½ an inch long. Okay, so right about there. Maybe I'll actually make it a little bit closer to it. Good idea to use a pencil for this, okay? Okay, this is going to be right there. Make sure it's like as much of a right angle as I can make it using a ruler, pencil, and paper. So about right there. Here to there. There we go, that's good. So again, I know because I just measured it that this side length is 1, this side length is root 3, so when I make my hypotenuse, I'm going to use that 1 and that root 3 to calculate it, right? And this is going to go so on and so forth and make a bigger and bigger spiral, and you'll see it's going to look like a nautilus shell as we do it, right? So I've got 1 squared plus root 3 squared is equal to c squared, so that's 1 plus 3 equals c squared, which is 4 equals c squared, which at this point is just going to be 2, right? So that means that this length is the square root of 4. We'll just write square root of 4, but it's going to be 2, so technically it should be roughly an inch long. Dang, Dave, good work. Look at that. So close. Good work. Okay, and so it's going to keep going and keep going and keep going, and the idea is that this is going to show us a structure found in nature that follows a mathematical formula, right? So this is the same thing that creates a nautilus shell, right? So if we kind of take a look at that, let's see if we can get this right here, okay? Yeah. Right? You can see that that is going to be very, very similar to what we are creating as it gets bigger and bigger and bigger, and it starts to spiral out and around on the paper, okay? So yeah, that's kind of the idea.